let's talk about horizontal modifications to trig functions now. So we've been talking about vertical modifications like equilibrium and amplitude, but what about horizontal modifications? What about stretches or shrinks of the horizontal nature? Well, let's get our graph of sine x to start off with. Sine x, remember that's just like an infinite squiggly. And the squigglies are every, I'm not going to label that one, just label this one, every 360 degrees, which is 2 pi radians. Remember, we're working in radians now, just a good habit to get into. So the squiggly repeats itself every 2 pi units. So by repeats, I mean like it does its squiggle up, squiggle down, and then it's ready for a squiggle up again. So I'm lumping this squiggle up, squiggle down into a single unit of sine. A single copy of sine, rather. So the period is how long it takes to repeat itself, how long it takes to repeat a copy. So period is from here to here, that's 2 pi, and then from here to here again, that's another 2 pi. So period is 2 pi. Now, what if you get a graph like sine of 2x? So the period, how you find the period of that graph? Well, first of all, that graph is gonna be shrinking a lot. Yeah, it's gonna be compressed. And how you find the period of that is you set this inside equal to 2 pi. So you say 2, let's call it p, 2p equals 2 pi, where p is the period. Then period is just pi. So this becomes pi, this becomes 2 pi, this becomes 3 pi, 4 pi, and so on. How about sine of a half x? Well, that now is going to become stretched this way. And let's do the 1/2 p equals 2 pi. Well, then p equals 4 pi. So period is going to be 4 pi here. So 4 pi, and then here would be 8 pi. So that's the deal with period. That's how you compute the period of a trig function. So let's try it with cosine. Just getting some more practice. Let's do a more challenging one. Let's take cosine of 3/4 pi x. All right, this is kind of a monster, but we'll get through it. So remember, the graph of cosine normally looks like this. Actually, let's move that. Let's move this over here and label this just with graph of cos of x. So graph of cosine normally has period 2 pi. Now the period is like squiggle, half squiggle down, full squiggle back, and then half squiggle up. So again, just repeating a single copy of itself until it gets back to where it started here. So period equals 2 pi. How do we do this? Well, we say 3/4 pi times the period has to equal 2 pi. And then we just solve. So then we get p equals, 3p equals multiplied by 2, and then we have 8, and then p equals 8/3. So now when we graph it, we're going to have the period now being 8/3, and then the next time it repeats up here, it'll be 16/3. So yeah, you just got to set the inside equal to 2 pi, find what the period is, and then label that on the graph. let's finish off with tangent. So with tangent of x, normally what that looks like, remember we've got our asymptotes at pi over 2, negative pi over 2, and 3 pi over 2, negative 3 pi over 2, and then it does that kind of swoopy thingy, or sigmoid thingy. And now the period here, this thing is being repeated over and over and over, and now the period here is pi units. From negative pi over 2 to pi over 2, that's just pi units. From pi over 2 to 3 pi over 2, that's pi. From here to here, that's also pi. So period equals pi units. So now if we wanted to find tangent of, say, like, just say 4x, tangent of 4x, now we'd say 4p equals pi instead of 2 pi, because the period is originally pi in tangent. So period now should be pi over 4. So now when we graph, instead of having a pi distance, we should have a pi over 4 distance between the asymptotes. So it'll be a lot narrower together. So these asymptotes will actually be negative pi over 8, pi over 8. And then the next one here, another pi over 4 units will be 3 pi over 8. And it just keeps going like that. So it's compressing a lot. And then, yeah, it looks kind of like that. And lastly, to finish it off, let's do one more example with tangent. Let's do, the pi's still there. Goodbye. Let's do tangent of, let's make it tangent of 1/3 pi x. So now we have to set 1/3 pi times the period has to equal pi. So cross out these pi's, then period equals 3. So this distance has to equal 3, this distance has to equal 3, this distance has to equal 3. So asymptotes should be at negative 1.5 and 1.5 and 4.5, likewise negative 4.5, and then we've got our tangent going between those. So there you go. That's how you deal with modifications to the period of trig functions.